So today it's going to be a bit of a special video. As you can see here, I have an Atari ST, but I'm going to talk about the Oric on the Atari at the same time. So I'm going to talk about Dungeon Master, which was also followed by Chaos Strike Back, but right now it's only Dungeon Master. In 1996, I made a prototype of an Oric version of Dungeon Master. And for various reasons, I was not able to go as far as I wanted. So, the game was released in 1997 and has been very, very successful on the Atari. So, I'm going to boot it on the real machine so you can see that it's not cheated. And this is the famous FTL, faster than light, intro screen. So while it's loading, I can present you the controls. So presents on the big Dungeon Master zooming logo. So this game was really exploiting the layout of the keyboard, which is on the Atari ST. You don't only have like on PC the 3 arrows, you also have insert and clear home, which are used to rotate left and right. And then you can choose from F1 to F4 to select one of the characters, escape to pause, and Control S to save. So very minimalistic UI, and everything else uses the mouse. So here I'm in the game, you can see the list of Dungeon Masters. And if I press Enter, we enter the dungeon. So, I played the game a bit and I pre-recorded, so I don't have to play during the video. So I'm going to switch back to the main PC setup. So, Dungeon Master, released in 1987 by Faster Than Light, or more exactly Software Heaven, Faster Than Light being the publisher. And very, very big hit on the machine. Because it was really a next generation game with simple but very clean graphics. But it was mostly that it was one of the first games which embraced the keyboard mouse setup. It was very, very natural to click on things. And many other games back in the days could not decide if they should use the keyboard or like the mouse, and you got some horrible things like the Psygnosis games like Obliterator or Barbarian, where you have to click on buttons to move, and yeah, terrible UI. So I always loved this game, and when I came back to the Oric world in 1996, I did try a few things related to demo making. But I really wanted to try, is it possible to make Dungeon Master on the Oric? So I made some old prototype, which look like that. Here it's a bit corrupted. It's a version I rebuilt, but the original version did not have this problem. So you can see we can open and close the doors. There are moving traps. Can get hurt. And this is basically the first level of the real Dungeon Master with just some added traps because I was testing things. And if I'm not mistaken, yeah, you can choose the current leader by choosing 1, 2, 3, 4, and maybe so yeah, very, very minimalistic version, and so that was in 96, and so that's about 24 years ago, and time flies. And people have been asking me, Debug, when do you make the new version? When do you finish the game? So This video is special because it goes hand in hand with an article on the OSDK website, in the article section, where I'm basically explaining everything which I'm doing in this video with the source code. So you can see the 96 prototype. That one was another one with a map auto-played. There were another version, which I don't have anymore, but you can see with even more primitive graphics in wireframe. And how the graphics were done. So basically green on black bitmap and nothing special. And some of the test graphics I did, so with the logo, what could it look like to go up and down the stairs with things that looks like the original Dungeon Master graphics, and some slightly different ones. And this is when you fall into a trap. But then I stopped the project for multiple reasons. And the first one was mostly that I did not have any idea on how to make the user interface work without the mice. On the original version, it's very natural to move with the key, select thing, pick item on the floor, put them in your inventory, or directly right-click, open the inventory, put something on the mouse to eat, or on the eye to examine. That does not work on the Oric because you don't have a mouse. So there are a few console versions, like Super Nintendo, which are entirely playable with a pad, with a virtual cursor that you can move around, but it is not very nice to play. So I've been thinking about some alternative version, like maybe single-player Dungeon Master, or maybe you single character, or you play one character and the three others are played automatically, and remove all virtual cursor. Just use a bunch of keyboard shortcuts to automatically do things like take items, maybe auto-select position, but that removes some of the discovery, like clicking on buttons on the walls, something like that. And then there was a problem of graphics. It was very meh, graphically, and very limited, and it was very hard to do things like monsters on top of the rest of the graphics. And the final thing was I had no idea how to use the floppy disk drive, which also means that I was very limited in terms of memory I could use. So fast forward 20 years, and now we have a lot of the problem which has been solved. Thanks to Twilight, we have the AIC graphic mode, where instead of just monochrome, we can do fancy things like doors that looks kind of woody. We can have sprites monsters with a splash of colors, and all these things can easily be put on the rest of the graphic because they have compatible palettes. And for reference, this is the Atari ST version of the graphics. So, not fabulous, but better. And we've been doing all these demos on Game on Floppy, so now we have a pretty good understanding of how the floppy disk drive system works. And we have loaders which are much more efficient than system things, can decompress data on the fly. So there's no problem for having all the levels of Dungeon Master on the floppy, and dynamically load sets of monsters. So there will be necessarily some adaptations, like you can't have all these monsters with all the animation phase in memory at the same time, but with some smart boundaries, loading in, loading out some elements, that's probably totally doable. I still have no solution on how to make the in-game interaction without a mouse, so if anyone has idea on suggestion of what will work, please share. One idea I had was to not make Dungeon Master, but maybe Dungeon Thief. you are a solo thief who need to enter the dungeon to steal something and go back on escape. No minimalistic inventory management, simplified puzzles. That would not be Dungeon Master, but that would be possible with just keyboard shortcuts. But I did not just want to stop on a failure, so I decided to redo the FTL intro. So you just saw the original, and I made it on the Oric. So in word activity, here is the Dungeon Master FTL intro. And with a list of credits. There is actual code, which you can find here at the end of the article, and it's in the description below. And this video is going to be there. That's a placeholder. So, here is how I did it. So, when you approach this kind of thing, don't think in terms of code, algorithm, or thing. Just try to take a piece of paper, pen, maybe a calculator, and do some quick and dirty calculations. So, when looking at this version, I was able to see that there were about 15 levels of zoom, give or take. The maximum size was this amount. You convert that in the Oric resolution, modulo the resolution, multiply by 16, how many do you have? I calculated that with a 216 by 60 pixels logo, that would be 2160 bytes per logo, multiplied by 16, 34 kilobytes. When you boot an Oric, it tells you it has 37 kilobyte free. And that's not even counting the 16 bytes of overlay memory, so there is no problem storing that. Without any optimization, reducing the black borders, absolutely no problem. With that, you know that all your graphics will fit in memory, so it's just a matter of knowing how are you going to have the different sizes. You could totally do that by program, by making a very smart algorithm when you try to divide, but that would be slow, and the result will not necessarily be pretty, because the resolution we are using on the Oric is very small, so 1 pixel here or 1 pixel there will look different. So why spend time trying to do a complicated zoom system with bytes which are multiple of 6 in size when you can just use a painting program, take the big one, and do the n size you care about. Advantage being that you can retweak, so I know that this pixel is not good, so I can tweak it here, maybe round that a bit more there. And then you just have a big picture that you load in memory, and then it's just a matter of display that one, display that one, display that one. And since they are all the same width, it's super easy. The code is absolutely trivial to make. And I'm not actually even loading the picture. The picture is part of the executable, which I present here. So I use pictconv in source code export mode. So I got my sound.s. The advantage is that I don't even have to do any computations of allocate memory on things. It's just a part of the memory with a label, source data, and they are just linear with 40 bytes per skyline. So to access each of the bitmap, I just made a small enum, present FTL master, which match each of the elements on the screen. And there, that's the skyline position. So 1, 18, 107, etc. On the small function, bit block, which given the number of the bitmap, just compute the starting position on the end position. The end position is the starting position of the next bitmap -2, because there is a small line to separate. And it's just a name copy from this location plus position start to the center of the screen, A00. And I added a small offset so I could display the master under the zooming dungeon. So you can just call it by doing bit block, number of the picture on the offset. And that's it. And this code here is 100% of the code used to display the dungeon that zooms. All it does is go from dungeon 1 to intro master, which is one just before, and just bleed it. Bloop, 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 bloop. And the fancy deserted fade on fill screen is just stuff I put before to clean the screen and do the transition effect with the blue lines and the color changes. So fill screen, which is just a mem set of 8,000 bytes, so absolutely nothing complicated. And as you can see here, it's all white. There is no yellow, no red, no blue. And the reason is, since I'm compressing the data, it's important to have all the black uninterrupted. If I had a color change, that would be attributes on the left side, which means that the right part of the black and the left side of the black will be interrupted by my attributes, and the compression ratio will not be as good. And another side effect of that is that it's much easier to choose the color if you want to do like maybe an orange by mixing yellow, red. It's much easier to do that in code than to modify the picture. And to do the coloring, I made this apply attribute function where you give the start of a buffer how much bytes to jump. By default it will be 40, but you can do 80, 120, 160, so you can jump more than one line. The number of lines to process and which attributes to write. So paper color and ink color, which I use there to do my fades, like write every 4 lines, every 2 lines, every line. And I also use that to colorize the bitmap directly, because the screen is 40 bytes long, large, and the bitmap itself is 40 bytes large, so I can use the apply attributes on either screen or the bitmap. So it's what I'm doing on startup, where I colorize the word dungeon in yellow, and the master in red over blue. So it's easy to do. And finally, there is the sound, the swoosh. Sound is relatively complicated to do on the Oric because the YM chip is accessed through the VAA interface chip, which is kind of a mess to program. So what I did is that I implemented a virtual sound chip system. It's what I use in my Quantum FX CEO 2019 New Year's Eve compo entry. So the 13 registers are exposed, actually 14. Frequency, noise, mixer, volume, and need update. And all you need to do is to put the values you want, like if they were the actual register of the chipset. And when you're done, need update equal 1. And every 50 times a second, my IRQ handler check if PSG need update is true, and if yes, update the physical registers of the YM chip by using these values, and that's it. So the swoosh, basically it's a volume going up and a frequency sweep on something which is like white noise, which is great because the YM chip has such a white noise generator. So the FTL logo is 88 pixels tall, and I'm drawing it vertically. So what I did is I'm using the Y coordinate from 0 to 88, and I use that to define the sound parameters. So as long as the volume, so first I need to enable the noise on canal on the first channel. So with setting everything to 1 except the bit 8, the value 8 on the mixer. And as long as the volume is less than 15, I just increase it, which gives me the... And for the noise sweep, if we are on the 32 first bytes, I increase the noise. And if we are between 32 and 88, as long as the noise frequency is above 0, on every 2 lines, so it's faster on the bottom and slower on the top, I decrement the noise frequency. And each one does a... And this is just to make the small color gradient. So I copy the new line, and at this position I put red, on the line under I put yellow, on the line under I do white. So the FTL logo appears white at the bottom with just a 2 pixel line transition with a red yellow gradient, so like a bit like a fade. And while I was at it, I decided to give a shot at drawing the Dungeon Master credits screen. The original is much more complicated. It has some wooden rolls, but I try to convert that with the difference of screen resolution, and the lack of colors, and the attribute constraint that just looked terrible. So it's much more simpler, and the only fancy thing I did is that normally on the original these letters are in red, but there were not enough room between the initial and the word to put the red change, so instead I use invert video. So the invert video of yellow gives me blue, and the invert video of black ink gives me white. So that looks medieval style, and that's good enough. So the project itself, when you unzip this Dungeon 2020 OSDK article, so you get data, including the font which is not used there, this picture there, and the graphics. And you have the code. So most of that is a floppy builder based, so what really matters for you is main intro, which is that's the entire source code of the thing. So main, install IRQ, load the font just because. Then I colorize the presents with black paper, which is already the case, and black ink, so it's invisible. And the reason I do that is because I want to make it appear. If it was white, it will flash to white before the fade, which is not good. Same thing with master, which I put in blue with a red logo and red text. And the entire area from the bigger dungeon logo to the smaller, I put with a blue background and a yellow color. And then I show my swooshing FTL, present, zooming dungeon, and at the end the loader scroll credits, so the picture with the credits. So the swooshing FTL. That's what I showed earlier. That's the entire code. Compute the location of the logo. Technically, I know it, so I did not have to do that, but it's just that it's practical. If I modify the graphics and I change this size there, I don't have to change the code. So, but technically, I could have done a generic function to extract that. So I have my source address, which is at the end of the logo, and my screen address, which is also at the end of the logo. I make sure the screen is black, and line by line, I draw and a final blit because of the way I'm doing this small gradient. on the last line, you can still see a bit of the yellow and red. So I just reblit the entire FTL logo on top, so it appears all white. Then I stop the sound, I wait 1 second, and I fade out. And fade out is a very complicated function which called apply attributes on the screen and wait 5 frames by having white, cyan, yellow, blue, and black. So it's what we call a fade on the Oric world. And then fill the screen again with 64, which is a neutral attribute, and I do that so the next effect starts always with a clean layer. Technically, I don't need to do it at the beginning and end, but it's not really great. Presence. So fill the screen, bleed block, present. That's all there is to do. And then this makes it appear, and this makes it disappear. And yeah, funny. I forgot. No, I had that originally in a function called fade in, but I did not. But yeah, not very complicated. So the dungeon that zooms, that entire logo, the entire code, and that's it. And regarding the sound processing, that's the entire code and even notal that is used. So that the virtual registers, that the sound processing, which is called every frame, and this is how you set the value of one particular register. That's the kind of thing I don't want to have in my code. The VIA is really messy. You need to select the right port and then the right register on the correct device. And you can't do that at the same time you are reading the keyboard, because the keyboard also uses VIA. So if you don't do that correctly, it's all very messy. Then that's the interrupt handler, which is the one I copy-paste between all my projects. On that one, even attempt to be clean by memorizing the old value to restore it later, for both the IRQ handler and the value. But yeah, so that's about it. So if you want to get the code, osdk.org and articles, and that's the last one. So this video is finished, but I'm going to leave the Dungeon Master game running, so you can see, if you have never played Dungeon Master, I actually finished the first level. There is no command, I was just playing the game. I did not even use any of the cheat I had, because I had plenty. Like, I had the 60 pages of maps of Dungeon Master, with all the hints, and I even had the list of all the characters: Iadori, Shibuni, Z Duke of Banville, Shani, Hawk. I think back in the day I was playing with Gosmog, Daru, Syrah, the Child of Nature, and yeah, I don't remember.